Well. Finally, the episode 40 of the Learning Kotlin Live. Lovely. So, today it's another day for manual reading. So, let's take a look at what we're going to read today. Although, I think we pretty much covered a lot already. Let's see. Basics, idioms. Oh, this is don't really care about the IDE part. Wow, that's a lot. That's probably something we might want to cover. Let's see if there is anything that is more important now. Well, beating with Gretel is something that I am definitely interested in, but I don't know if you guys are interested in this one. So let me know if you want me to take a look at this, because I'm not a Gretel pro as well, but to explain these we will need to have a lot of Gretel knowledge, which I may have or may not, but the most important of all, I hope you guys can tell me if you're interested in that. So the structuring, we have already looked at this. Collections, ranges. Well, this is actually looks promising actually. Have we covered collection already? No? Yes? Let me take a look at it. I don't think we have covered this. Oh, actually we did. We have covered this in episode 36 already. So in 38 we talked about idioms. So yeah, ranges is probably something we can talk about now. But ranges just seems to be so easy. Oh, it's okay. It's actually going into the details. So, well, why not? Maybe it's worth it. So these range expressions are formed with range2 functions that have the operator from operator form triple dot, which is complemented by in and not in. Oh, actually not in. There's a not in. Okay. Range is defined for any comparable type. Oh, this range is actually okay. Let's see, for boolean and a range, if it has an optimized implementation. Okay, it's done by comparable interface, but for in integral primitive type, it has an optimized implementation, which int range, long range, char range. Let's take a look at a definition of this. Huh? Android developers? No. That's not what I'm looking for. Class identity range is there's a start and an end inclusive. So that's the constructor of it. Oh well, pretty self-explanatory. So only for integral type, they can be iterated over. So the compiler takes care of converting analogously to Java's indexed for loop. Makes sense without extra overhead. Yeah, that's nice. That's nice to know, but not really something I care about a lot. So you also have a down to. And you also have a step, and yeah, these are things that we already know. Oh, so 4 down to 1 in step 2, it's still step 2, not step -2. Okay. So to create a range which does not include its end, you can use until. Yeah, we have already used this a lot. So here's what I'm interested in, how it works. So there's a interface called closed range. Look, int range is implementing closed range of integer. Nice. So closed range has probably two of type t, probably have two t, which is an end inclusive, and a start. Okay. And these two need to be comparable. Oh yeah, there it is. A closed range is implementing a t, which should be a comparable of t. Let's read it this way. A closed range of type t is implementing. Not really. Wait. Really? Wait a minute. Wait a moment. Closed range. So this is probably the kind of the wildcard. No, not a wildcard. This is just close range of type t, where t needs to be a comparable of type t. T should be implementing comparable. Of type t. Okay, I'm going to close this. The main operation of it is contains. Contains? Really? Why? Oh, okay, contains is used with its implementation is probably just check the two, check the value. Where is that specified value? There it is. Contain extension. It has a lot of extension functions. And it is extending every. Why is there a crossover? Deprecated? Yeah, deprecated. It's only for. Okay, that's a float and byte. Yeah, it's okay. So these are going to be removed, so we don't operate with them. Okay. Well, let's not look into the details, but basically there are a lot of overloading contains extension functions. So there is also progression types. Let's take a look at the integer range, and it is implementing the integer progression where there is this first, last, and step. First, last, and step, spelled self-explanatory. A progression is a type of iterable. Wait a minute. A progression is a subtype of iterable, and so let's take a look at the progression again. It's a type of iterable of integer, so that makes it itself iterable. When if n is an integer long or char, like here integer progression, long progression, and character progression. So it can be used in for loops and functions like map. That is exactly why we use this for in something loop, because this item here is a closed range, and for close range, for integer close range, for integer range, long range, and char range, character range, they are also iterable. So that's what happened in this syntax basically. For integral types, the double dot operator creates an object which implements both close range and something progression, which are integer and where are they? Wait a minute. For integral types. So can we see the implementation of close range here? Is there not a known implement? No, there's no such thing in Kotlin. Anyway, there are just probably so many of them, integer range, and it does not give an example, but my guess suggests that there is probably a double range of Kotlin. Nope. Oh, there it is, double range. Actually, no, this is not from a standard library. So how about byte range? Nope. There's no byte range. Huh? How about long range? There it is, finally. So yeah, there's a long range where we have a long implementing a long progression and a close range of long. So there are functions that are defined in integer progression, like down to and step. So they are also available for these progression types. The result of the down to and step function. Wait a minute. Progression down to and step. I think it means that down to, the return type of down to is it's an integer if it's in integer progression. Let's see, down to. Hey, where's down to? Step. Oh, okay. Result of the down to and step. So where's the down to? I can see the step, and yeah, indeed it is returning an integer, but where's the step? Iterable maybe? Step? Nope. Where does the step come from then? Ah, there it is. Step. Oh, wait. What? Okay, down to. Yeah, where's that down to? I don't see one. I think it's defined in range actually. No. Where is the down to defined? Kotlin. Oh, okay. It's actually an infix function. Okay, infix extension. And actually it returns an integer progression. So no, it was lying. This is something that we need to be changed. Let's add this page then. Yeah, why not? Where is it? Where am I? the result of the down to and step function is always a, oh yeah, down to is a progression, and where is it? Down to, and where Kotlin dot ranges, where is the step and down to, until, and probably the double dot, which can be defined as anti-range, probably, I don't know. That's a little bit too hard for me. Infix functions, range to, reversed, step, until. Yeah, wait, can't find it actually. Oh, operator function, close range. There it is. This is probably the operator function contains. This is probably where, I don't know actually. Yeah, it contains. And until. Okay, so they are all always some type progression. So I think it's going to be further discussed here. Constructed with the form closed range function defined in their companion objects. Progressions from closed range. Okay, there it is. And we have a start and a step. That is exactly what we have provided here. Start and a step. The last element of the progression is calculated to find maximum value not greater than the end value. Yeah, this is just again just illustrating what these anchors are used. So range to, the range to operator on integral type simply called a constructor of range classes. Okay, so I actually don't need to change it. It's actually pretty correct. Let me check again. The result of down to and step are progression. So let's take a look at the down to and down to. There it is. It's a progression. And step, I guess. Yeah, step. And take a look at that step, and yes, it is returning a progression. So what else is returning a progression? Down to, we already know this. And step, we already know this, yeah. Oh, as well. Reverse, yeah, makes sense. And yeah, that's probably all we need now. Utility functions. So range 2. Range 2 is an operator function which we just found there. And floating points do not define the range 2 operator, and the one provided for generic comparable type is used instead. Okay, double and float are comparable, so they're using the comparable one because we are only optimizing the the integral types. That's something they have mentioned here. So if it is not only for integral primitive types, we have optimizations. Else, we always use the comparable one. And range 2, it returns long range. Yeah, that's. And long range itself is a progression. It's a long progression. So the range 2 here is basically this double dot operator here, and there with this syntax we have this syntax. No, actually this syntax. We have a progression type. With this, we have a progression type as well. And this progression was actually an integer range. So it can serve in both a for loop and not, and maybe it can also serve not a for loop, but for these items it only serves in for loops, not a if statement. So reverse, yeah, this is self-explanatory again. And for step, yeah, it's also, so for we're actually passing let me see what parameters that a step take. A step takes an, okay, it's actually it's an infix function, so what it takes is actually an, oops, sorry, what it takes is an integer progression and an integer. So where's the this is the integer progression part, and this is the integer. And because it is infix, so it can be step here. It is infix, so we can provide the integer progression here and another integer here. And with these items combined, we will have an integer progression. So that's the whole idea behind this step. Note that the last value of the return progression may become different from the last value of the original progression. Dot last. Oh. Okay, so here we have last with 12, but when we have step 2, it becomes 11. And if we have step 3, then it becomes 10 and 9 and goes on. Just a pitfall. So let's range. Type checks and cast. Have we mentioned this already? Uncheck cast, I don't think so. Unsave cast operator. Yeah, I tend to believe we haven't covered this yet. Let me check for a minute. Cast. At least I have not covered this since episode 13, but maybe in, well, I covered this a little bit in episode 3 and episode 10, but I tend to believe it's not enough. But let's skip that for now. So I guess that's all we have today, because if we try to include the type check, then we will probably be over time. Let me know if you have any questions around what we mentioned today or in earlier episodes, so that I can answer you now. Or if there's no questions in the chat, let me see if there's anything we can talk more about. Maybe we can just take this chance to review the infix and operator keywords. Infix function and operator functions. Are they functions? Yeah. Wait a minute. Oh yeah, operator functions. So let's take a look at it. So this part is actually already covered in, let's see, in episode, one moment, episode 30. So if you're interested in this page, just visit the episode 30. So let's see. Yeah, I was going to talk about infix notation. So infix functions are actually just like extension functions. Wait. Are they infix notation, and it fills in the function usage part. Okay, so yeah, infix function are always extension functions. So it actually takes two parameters. One is the list, this one, and it's declared here, and the second operator is declared here. And these infix function notation are just a way for you to skip the dot and left and right parentheses. So it's just like an operator. It can be used like an operator. 1 and shift left 2, and this is exactly what we have seen in the range 2, in the ranges. Wait a minute. This is exactly what we have seen here. In, I think in is in operate. Let's see, in. Where's the in from? That's actually interesting. I think it's in integer extension in Kotlin. Can't find it now. In. Nope, I don't see it. Maybe it's in an operator. Kotlin. Give me the doc. I need a doc. Hey, you only explain. That's not what I want. Well, maybe we can cover this in the operator overloading lesson, which is just upcoming. But anyway, let's come back to the step itself is an infix function. Down to is an infix function as well. And until. Well, these are all infix functions, but actually it's pretty obvious. It's in the bold form, so it's probably an operator, and yeah, and it's an operator. So and is an operator. Let me take a look at these int range. I need an int progression. There it is. I think it's the contains operator. Kotlin contains operator. Wow, let's take a pick at it. Contains. Yeah, there it is. In is translated into contains. A and B is translated into B dot contains A, and this is how not in is translated as well. So operators, we'll soon cover this. That's all for today. Let's take a look at if anyone is saying anything in the channel. No. So given no one speaking, that's all for today. Thank you for watching, and we'll see you soon. Bye bye.